Okay, so far we did very basic graphical user interface testing, something like this, essentially taking the text entered by the user in the expression field and setting it in the result field. So this is our click handler in the controller class. We will discuss the business of controller in our next presentation on JavaFX. So the next thing I would like to demonstrate is how to connect the graphical user interface front end with business objects that we developed in assignment 2. So we need to create the package for our business objects and then copy files from assignment 2. So let's take a look at the assignment 2 structure. So we had our source and the package name was this, and we had some files over here. So let's first create this package. New package. Same name, and click Finish. And we can copy these files, AST node, lexer, and token string. Right? Copy. And paste them under the new package with the same name. Okay, under assignment A4. So these are our business objects that we would like to use in this desktop calculator implementation. So they of course already appearing in our project structure. Let's add a note to our notes. So we copied the files from assignment 2. In the original version of the calculator, we had a console interface application. Let's bring it back under assignment 2. This was our main class with the main method that looked like this, with entire interface handled here. So let's make some updates in our button click handler to adopt this logic in our new GUI environment. So this is our controller that contains the click handler called onClick evaluate. So the first thing that's required here is to use the string builder with our lexer class. I can try to replace this line with the string builder. So we can use the string builder to construct the string builder object from our expression input. Let's make sure that we fix all the imports. Now we can construct our lexer object from the string builder input. So this will look like this. Once again, we can fix the imports. Okay, so these are all the imports that are listed here on top of our controller. So we are using AST node and the lexer class in this new implementation. And since I already added support for variables in my desktop calculator, now it requires this parameter, the symbol table, to construct the lexer. So this differs from the original version just a little bit. The next step is to call the start rule, which returns back the root node of the abstract syntax tree. Let's take a quick look at this start rule method. So this is a start rule. First thing it does, it tokenizes the input, then it initializes the token stream, and then returns the expression rule, which is the top entry point into our desktop calculator grammar. So this returns the root node of our abstract syntax tree. So we can do the same thing in our controller implementation. All right, so the next step may be this. Just to invoke the start rule. Then as you can see, if there is an error, we can do the same thing. If there is an error, we can show the error text in our result box. Right, so the result value is a string that contains the error description in case if start rule resulted in error. Otherwise, we need to call a result evaluate. So this will actually evaluate the arithmetic expression. So let's just say else. We can call evaluate. Something like this might work. So we call evaluate. and then convert it to string. So this returns a double data type. So we convert it to string using the double helper class, and then set result accordingly. Let me show you my version of evaluate inside AST node class. Just scroll down to find it here. Okay, so evaluate switches on the type of the node, does all the arithmetics, everything we already discussed. And in cases where the division is involved, what I did here was I checked the divisor to see if it's 0 or not. And in case if it is, I throw arithmetic exception. So arithmetic exception is a runtime exception that does not force you to have a try and catch block. But I will add this try and catch block now because it's just pure convenience to be able to catch these errors reported by our evaluation logic. So let's go back to the controller and say, okay, we can try this. And then basically just wrap this in a try and catch block. And then we'll catch an arithmetic expression. Right here, this will be our arithmetic exception. And in case if we get this exception, we can still display the result in the same result box. So let's make it visible side by side. Just move this to the next document tab group like this. So this is my version of evaluate, and in cases where we do division or the remainder operator, which also requires division, I just check if the divisor is 0, then arithmetic exception is thrown and initialized with this descriptive message. So there are basically 3 possibilities of new version of evaluate. So it may be grammar error, which we catch with the error type of the node returned from the start rule, and we report this grammar error. Or if everything goes well, then we just display the result of the expression. Or if there's division by 0, arithmetic exception will be thrown right here in these 2 instances, and in that case we should be reporting expression evaluation error. So let's save these changes and do a quick test. Let's see how this blank line works. Just click evaluate, it results in a 0. Then we can try something trivial like single number or number plus another number multiplied by something. Now we can try to assign a variable x equals this, and then try just x. Okay, so this works. Then set 0, go back to x. Looks fine. Let's try some syntax errors, like for instance just a junk input. So this returns the syntax error of the expression. Obviously we have undefined variable, so our Alexa thinks that this is an undefined variable, which is true. Alright, and we can also say x divided by 0. So this throws the arithmetic exception and says error cannot divide by 0. Right, so this was our example where I throw this arithmetic exception from my code, and this truly becomes a way to communicate errors throughout the entire application. So it's very nice to be able to catch an exception like this and report it here. Some more testing, like for instance just a dangling plus sign, that should result in, yeah, it reports an error that plus is a binary operator, so it cannot be used just like this by itself. One improvement that I could recommend doing here is, instead of reporting the error in the result field, you could add another text field specifically for errors and make it visible if there's any kind of error related to user input. And it should be very easy to do because we have pretty good control over these 3 cases. So basically here we're reporting a syntax error. If everything goes well, this will set the result of expression evaluation. Otherwise, we may be reporting evaluation errors on this line. Okay, so this is our overview of assignment A4, JavaFX version of desktop calculator.